I'm a bit tired tonight. Uh, yeah.
Greetings.
So yesterday we implemented a new lighting system, and I also started on adding editor support for that. And today I spent a little bit of time actually getting that going. So let me just show that off real quick. Let's make something like this, and then I can just middle click to where I want the polygons to be, and it'll make a thing. There you go. Now we got lighting, and since that's an entity, I can also move it around and, do your usual stuff.
How pretty.
Okay. So there's several things to do with lighting that I still want to get to. Two of those are absorption maps, I guess, and the other is shadow maps. Absorption maps, the idea being that in addition to the albedo value, so the color value, you also define an absorption factor, which defines how much light is absorbed by the current pixel in the texture. And that would allow me to sort of, so I don't have to, as right now, when I make a light, I have to like make sure I trace the outline, because it's just going to go through it otherwise. And it's also, when I do trace the outline, it doesn't have like a sheen on the edge of it or anything. With absorption maps, I would define for each tile how far the light can penetrate, and then it uses that information to sort of, diminish the light as it gets inward. And so I could, quickly draw the light like this, and it would automatically apply this kind of diminishing light effect on the tiles. This could also be used to make things appear a bit more, appear to have some kind of density, so I can make the light diminish less quickly on the upper parts of the stones and things like that, so that there's some kind of fall three-dimensionality in things. I could use the same in the sprites if I want to make it animated to add a bit of depth, but I don't know yet about that. Okay, so that's that idea. The shadow maps idea is simply, well, shadows. So mostly shadows of global illumination. So we have a sunlight, and I would like to have things like caves here to automatically be in some amount of shadow. And in order to do this, we need to calculate a shadow map so that whenever you look up a pixel here or wherever, you know whether that point is in shadow or not. Now, for something simple, you could do a one-dimensional sort of array along the entire chunk that does a scan line across the chunk and sort of notes at which points or at which height the block appears. So for instance, here at this value would have the height of this block, and here you would have the value of this block. And then in the fragment shader, you could use this height value and compare that against the current height to see whether the point is in shadow or not. That's one idea. The problem with that idea is that it doesn't work unless your light is shining directly downwards. And I would really like to have a way to, in the very least, vary the way the sunlight shines, so which means the shadows have to change directions. and they can't just be top down anymore. And I'm actually not quite sure how to go about that, in the very least not without either doing very expensive calculations on the CPU every frame.
What about light scatter?
What do you mean light scatter? Do you mean reflectiveness or ambient occlusion or what?
I mean that even if the light comes from directly above, the light would still affect some areas in the shadow as it scatters from where it hits directly.
Oh, yeah, sure. I mean, we can't do that. No game does that. Unless you're using ray tracing. No, nobody does that because it's way too expensive. Unless you have like an RTX card, and even then it looks kind of shitty. No, that's just not a factor. All you do is sort of, not make a complete shadow. That's it. You don't make it black, you make it some lighter shade. Or lighter amount of shade. Anyway, so I'm not quite sure how to do this, especially...
That's not very physics of them.
You need to render 60 times a second. You don't have time. You just don't have time. Okay. So I'm actually, I'm not sure how to do about this. I've been trying to think about it, but today has been a kind of a busy day, so I haven't had the time to. One idea that occurred to me just briefly before the stream was to sort of use a rendering pass that works in sort of two ways. Let me see if I can draw up the idea. I also need to start music. Let's get into Krita here. That's not big enough. Okay, so the idea I have is as follows. Let's assume you have some kind of polygon or whatever, some kind of terrain. Like this, I guess. Okay. That's our terrain. And so in this shader pass you render the geometry again. So the terrain, only the solid parts of the terrain get rendered, so not the background layers or whatever. So you render that onto a buffer and you set it to be black entirely. And then you do that again the next frame you draw the same geometry again, but also you make use of what happened last frame and you offset that by the direction of the light. So 1 pixel vertically and however many pixels you need horizontally to get that shade value or that direction going. And then you do that again, and sort of as time passes you build up the actual shading. this. You know. That was an idea I had. So you repeat that just, you know, forever. The problem, this kind of idea seems to work. The obvious disadvantage is that the shadow is sort of going to build up over time as you render more frames. But that's not really the biggest problem. The biggest problem is that what you see, your view isn't static. So when you move, it's sort of going to trail behind. And it's not actually ever going to clear the old values out. So there's no way to clear the shadow art, or no way to know when to clear and start anew. So I don't think this approach can work. But I don't know how else to do this either. So let's say, what would our ideal way of doing this be? Say something like this. So here we have, whoops. I fucked it up. Oh, got it. Like that. But then you would also have this. That's the actual shadow that we want in the end. So essentially what we want to end up with is a buffer that looks like this. Because then we can simply use this information, look up the exact same pixel when we render it, and detect whether it's in shadow or not. The problem is arriving at this map. In 3D, how you do this typically is you change the perspective transformation that you use. So instead of how you typically render your scene from the camera's point of view, you switch the point of view to that of the light, and then you simply render the scene onto a texture from that viewpoint, and that'll give you the shadow map that you can use to look things up. But in 2D, I can't do that because I don't actually have any geometry like this. I only have an implicit geometry based on the data I have in the tile map. So I can't use any kind of like perspective tricks to get this map going. I could do that if my geometry was built on polygons, because then I could turn those into 3D and I could, you know, render them with texture. But yeah. So the question becomes on how to do that. Another option would be to simply do the first suggestion I had, but in a single pass, which means that we would draw things, the geometry as black onto a texture, and then use a fragment shader that simply scans along its axis or along the shadow direction until it finds something that's black, and if it does, it sets its own pixel as black, and if it doesn't, it remains blank. The problem with that is it requires an enormous amount of fragment lookups, and those are very, very expensive, so I don't think that's a feasible technique. Because, you know, if your angle is very steep, so yeah, in the worst case you would have you would have to, for each pixel, you would have to scan with number of other pixels on the order of that size, and that's way too expensive. So I don't think that's a good idea. Hmm. One thing that we could potentially do is solve a linear equation, which is to say we go back to the original idea of using a one-dimensional array that tells us where things are in shadow. The difference being here that now for each point we do this, but we shift the array by the offset that we have. So instead of the array being, let's make a new thing here. Instead of the array simply covering, you know, this area, it would now cover this area, I guess. And then for each fragment, you construct a line. So if we wanted to evaluate this point here, you construct a line from there with the direction of the shadow cost and calculate when it hits the bottom of our view, and that will give you the value of the value to look up in the shadow array. I think that should be cheap enough to do. Though I think we can't just shift this, so we can't just have hold on. You can't just have a single array for the bottom, because if you have even steeper angles, so for instance, if the light is coming completely from the right, then it's not going to hit anything, or you can't really shift it far enough because it goes out into the infinite. So I would need to have an array for each side of the view instead. And then, you know, render things on there and... Yeah, so we would have to... Oh god, we would have to solve two equations, one for x and one for y, whether they ever hit 0 in either, well, four equations, really. Though that seems like the most likely solution to this problem. So again, you would have a look like this, and then you would do that. Or if you're here, you check it there. So now the question remains on how you actually build these. I suppose you would have to do 2 passes. In the first pass you go through every pixel and simply write out to... for all the black valleys you write out to their corresponding mapped pixel in the red arrays, and then in the actual rendering you use those. I don't know how you can write out to these kinds of things. Open GL shader, write to buffer. I think there is a way of doing that. I'm pretty sure there has to be. So the only feasible things that I'm seeing here are shader storage buffer objects and image load stores, but both of those require GL 4.2 plus, I think even 4.3 for SSBOs, I don't remember. I really don't want to do this CPU side. Yeah, so essentially, as far as I can tell, this technique would require for each pixel or each fragment to solve 4 linear systems. Independent ones in the very least, but still. And then also be able to write out to that story. Oh god, I'm yawning. Let's Google for whether other people have done this stuff. One of the people is just doing the, you know, the first thing that I dismissed, which is for each pixel you scan along a line, each fragment in that trace to see whether it hits a shadow thing, but I really don't want to do that because you have to bail out early, and even if you don't, invoking 100 texture reads per fragment is actually already really bad on Intel hardware, as I remember from previous times. Most of the stuff I'm finding is for top-down stuff, but I don't know. I can't find anything useful. The only things I see are algorithms that depend on having explicit geometry. Which I could do that. I could rasterize what I have. So rasterize the tiles into a set of polygons that can then be used, or, you know, a set of yeah, polygons that can be used to create a shadow map. But yeah, I don't think I want to do that. I would really like to keep this without having to discretize. Another idea I had is to... No, I can't do that. Never mind. If I could write to textures, it would be fine. Write to textures at arbitrary points. But, that's GL 4.2. How many do have GL 4.2? Availability. Come. Why is there no easy site to see, you know, usage or availability statistics for OpenGL extensions? I fucking hate that. Let's see. Wikipedia says GeForce 400.
I tried to do some searching and mostly just found completely unrelated white papers.
Okay, GeForce 400, so that's since 2010. Radeon 5000, that's since 2009. And Haswell for Intel, that's since 2013. It's a long amount of time, but I wouldn't be surprised if a lot of people don't have that kind of hardware even now. Well, image load store seems like an interesting thing, though. Let's see. Image variables. Let's see. Let me actually get this on the screen so you guys just don't just stare at that forever. Guess I'll just do it like this. Okay. So I'm reading the page on the both image load store and the memory model on the OpenGL wiki. Bigger maybe. Okay. Because apparently using Brights in image load store is qualified as incoherent memory access. GL memory barrier, probably what I need. So restore, and then want to read it back on the CPU, we should use short storage buffer. access barriers. Okay. So I'm gonna have to use that. Interesting. Alright, so how does load store work? Let's see. It's a bit big. Uniform storage qualifier. Okay, that's fine. Okay, so I think during the writing we don't actually need to care at all, because we only ever write the same value into the array. Using write only on one thing and read only on the other one. Okay. Yeah. Image write, image store, okay. Yeah. Exchange and compare swap, that's cool. We don't need any of that. Okay. Okay, yeah, that's a really nice feature in 4.2 that I haven't been able to make use of, being able to declare the binding point of a texture or other thing right in the shader, because otherwise you need to set that uniform to the value you bind the texture to, which is another write that could be spared. Okay, so this is going to be a GL 4.2 feature. Typically, I work within the constraints of GL 3.3, which is usually enough for everything, but for this, I don't see how to do it efficiently without severe caveats. So, yeah. This is gonna be an adventure into something new that I haven't used before. Exciting. Alright. Let's close this for now. Shadows.list. Okay. So how are we gonna do this? How are we gonna do this, indeed? Okay, so the basic idea is, one, find an image for the storage of shadow values at the borders of the current view. Two, render chunk and other casting geometry, but instead writing color value, solve for linear systems to cast array from the current fragment position to the four borders of the view in the direction of the light. Wherever the system solution provides index in range of the border. Actually, I only need to solve it once, right? Yeah. Solve a linear system to cast array from the current fragment position to the border. Wait, no. Hold on. I'm getting confused. I need to solve up to 2 systems. Range of the border, set the store. Okay. Six. Find the same image and render as usual. During the lighting phase, perform the same linear system solve to look up the value in the shadow texture or shadow image, and dim the light if the read if we read something. Okay. So the first step is a shader that can do the I'm also not sure, actually, let me look at the image load store. So when you actually write into the image, what kind of coordinate do you give? USL image store. It's an integer. Okay, so it's like texels. Okay, I get you. Alrighty. So, as far as I understand, you would do something like image to the uniform, image to the what was it? We're actually layout finding 0, uniform image to the shadow, and then what main? This is for the store, or whatever. Wait. So again, we can do the same thing as we did during the standard lighting thing, which is use this to get the actual position in view space. Without the offset value. Okay, so that's our current position, and then we need a uniform back to light direction. And we're just gonna default that to X, Y, -1 or something like that. Okay. So the reason why we need up to 2 linear system solves is because first we only need to solve for the borders that are in the direction of the light anyway, which is at most 2, and if our first solve does not hit a border, then we need to do a second solve, but if it does, we don't need to do that either. Okay, so how do we do that? Because I completely forgot. Let me quickly write it out on math paper stuff. So essentially we have the equation of x plus t equals k. Hold on. Yeah. So, man, my brain is not working. Okay, let's see. So we're gonna solve for x first, or should we solve for y first? Probably should solve for y first. Okay, if lights were if lights direction. Maybe I can do that in a smarter way. Let's just do it the primitive way first, you know. But there's definitely room for optimizations here that I can see. Okay, so first we test for y equals 0, so that's float t equals y or 0. 0 minus d cos of y divided by d x direction of y. And then this gives us the t at which our ray will hit bottom. And now we need to do x insert to get the position. So float x is cos dot x plus x times t. And now if x is 0 is smaller or equal to x, and x is smaller than, what was it, image size, I believe you can do. Image size. Okay, if we are in there, then we have a successful hit, and we can write it out. If we do not, then we need to test again. Yeah, we can probably fake this parameter here or something. I'm not sure. Image store. How did you do that? Store. Shadow. I've got 2. X is going to be X and Y is going to be 0. And the data. So we're going to have a red texture. Like 4, 1, I guess. Okay. I think I can actually get this done. Float y is Right, direction dot y smaller to 0. Smaller than 0 than y 0. Otherwise, it is size dot y. So y, and then -1 actually. Okay, so we didn't have success, so it needs to be hitting at the ceiling or the bottom, so it needs to be hitting somewhere at the bottom. Let's also make this ym for max. Yeah, okay. So now we need to again recalculate t. And this time we solve it for x. I wonder if there's a faster way of doing this instead of doing these two solves. Okay. And here we have to get a hit. I don't think it's possible to get a hit twice. No, yeah. You always have either one of those two. Next door. Shadow. Back to X. Y. Wait, that's not right. Y then. Snap Y. Okay, so that should be the store. Let me actually encapsulate this into a function because we're gonna need it again in the other one.
The else is missing a curly bracket.
It is indeed. Thank you. So should probably actually. Doesn't matter now, but I should have written this in a GLSL buffer, then I would get syntax highlighting and everything. Anyway, shadow map position. I like to pause, I guess. And to the sides.
I was wondering why you weren't doing that, but figured you just didn't have a GLSL mode installed.
I do, I'm just lazy. There we go. Now we got it. Stop. Okay. Positive X. Oh wait, there's no brackets around the return. I forgot about that. Okay. So now we can simplify this to just be image store shadow map position pause size light direction X41. Oh my god, I hate this track so much. God damn it. Okay. Probably just put everything into... Okay. Void main... 2... So this is for the load. Image load. What does that return? Probably a vec4, right? Yeah. Or... There we go. I mean, I could put this stuff in... I don't know. Probably better to keep it like this. Okay. So this should be our two functions that we want to use to get the data out. Okay, so now for the more difficult part, which is figuring out how to tie this all together. So we need a new shader pass, that's for sure. Shadow map pass. It's gonna be... It's gonna be for object pass, which has a... well, it doesn't really have any outputs at all. Yeah, so it doesn't have any output buffers at all. We'd render to nothing. Okay. Where's the lighting stuff? I wish I could, like, redirect color rights or whatever. That would be cool. Maybe I can. I'm thinking of it, but okay. How did I do the trial shadow map pass here? Their own viewport. Could probably make the support type image. That will be interesting. Oh yeah, here it does that part. I can't do that though. Shadow map pass. Fragment shader. I might be able to do something here. In fact, I wonder if it would be possible to map everything into one, meaning we don't have a separate pass to do the shadow rendering at all. No, that wouldn't work. Never mind. But in that case, the problem of the output would not be an issue. Okay. Where is the stuff? B. Shadow. Lookup. Mixin. Okay. Shadow render plus. Okay. This is actually not correct because we are now always doing the store regardless of whether anything was drawn here at all. Okay, so there's a couple of things that need to be done. First of all, we need to ensure that we only draw the chunks at the correct layer. So, hold on. point. Region. Cross, shadow, map, cross. Oh, I see how it is, okay. How's Never mind. Okay. I'm gonna need to look at some stuff. No, not that. What is it? First plus shooter, I believe. Instance, shadow, class of chunk, fragment, shooter. Okay, layout. Where's the chunk stuff? I'm confused. Where's all that? Oh, did I accidentally override things from trial? Yeah, I did. Same. What? For symbol? What are you talking about? Oh. Fine. Okay, here we go. That's more like it. So we still have this outlet for color, which is a thorn in my eyes. Is it initialized to anything? Honestly, it would be better if we... store, though. Color is not... It's initialized to the textile fetch. I'm not sure if this is going to work or not, given that we don't have a color buffer attached to render to. It's also, you know, doing way too much. It doesn't actually need to... Well, yeah, it doesn't need to apply lighting or anything. Sampler isn't even going to be attached. This is awful. Oh, God. I don't know how to deal with this in a good way. I really do not. This is a problem in the shader composition facilities in Trial. I mean, it's going to work like this, but it's going to do... well, it's kind of going to work, but... honestly, the apply lighting thing should not be here. Should not be here. Can I inhibit that? No, wait, the chunk does that in its own. Because of the offset thingy. Fuck. I can, you know, get it working if I futz with things and add additional classes and other shit, but I really would rather not. Okay, well, let me just see how things go from here. So, we have a shadow map pass. We don't have the attached shadow image yet. I think I need an additional way of handling that in the process. I would like to have it as a port type so you can, you know, connect it and stuff, and it's allocated as part of the initialization, but let's see. What did you use for that? For the binding. Bind image texture. Simple look. Okay. We need a new text, new port type, I believe. So that's annoying. Class image. Binding. This is really annoying. Should be a text report too. Okay, so GL bind image texture as a layered argument and a layer argument. I don't quite understand those. Texture is the name of a one or two-dimensional array texture, 3D texture or cube map or cube map array texture or two-dimensional multi-sample array texture. Possible to bind either the entire array or only a single layer of the array to the image unit. In such cases, if layered is GL true, the entire array is attached. Okay. Yeah, otherwise the value has no effect. Okay. It actually gives me a bit of a problem. What if we want to bind the same texture to multiple spots? Especially multiple levels of the I guess I'll fix me. I'm just gonna leave those out completely now. For now. Access. What is access? Okay, whether it's read-only, write-only, or rewrite. Okay. Oh right, I also need to...
I feel like I'm losing hope in my body and my soul and the sky. It looks so ominous, and as time comes to a halt, silence starts to overflow. My cries are inconspicuous. Tell me, God, are you punishing me? Is this the price I'm paying for my past mistakes?
format.
This is my redemption song. I need you more than ever right
So you
now.
can specify different formats
Can you
for the binding.
hear me now? 'Cause we're gonna shout it loud.
Not exactly. The format parameter for the image unit need not exactly match the texture internal format, as long as the formats are considered compatible as defined in the OpenGL specification. What? Okay. I'm just gonna ignore that stuff for now.
Maybe if I keep believing, my dreams will come.
Okay.
Come to life.
Let's see. Generate pause program. Yeah, okay. So this is a function that creates a function that is used to initialize all the states. It is done like this to cache stuff, or rather it performs a form of JIT, which is, you know, for performance stuff, and also because I thought it would be fun. Mostly, not because of any actual reasons in performance to do stuff. Okay, so this is not a uniform port, which is good. There's a texture port. So let's do that. Type of case ports. Uniform Yeah, find image. Yeah, didn't think that was gonna be there. Find image texture. So the unit is gonna be the binding of the ports. Texture is gonna be name texture ports. Level is gonna be 0. Layered is gonna be no, there's gonna be 0. Or wait, that's gonna be T. Access is going to be access port. And format is going to be internal format. Okay. Okay, so that should allow me. I don't know yet. Okay, yeah. Okay, so in the shadow map pass, we're now going to have a new port, which is going to be the shadow port type image. Image port. Access is going to be writes only, and binding is going to be 0. I think that's what I called it. Yes. Okay. And in a render pass, we're gonna have that again, but this time it's read only. We don't have input and output ports equivalent yet, which would be nice because those would allow us to, you know, check that stuff is consistent and whatever, but I'll worry about that another time. Okay, so main, our pipeline is going to become more complicated. Okay, so we're going to have a shadow map, like instance, shadow map pass. And our rendering pass is going to need to be not just a render pass, but a shadow render pass as well. Okay. And then we need to connect port shadow to the rendering. There we go. Here goes nothing. Crash. Tile set required. That's an interesting one. I haven't heard that one before. That is very unexpected. What? What do you mean? Also, let me rename this file to shadow map. Where is the wedding? Did I accidentally save the thing and trash the world? What does that say? No, I did not. Interesting. Load her up. Why is it loading everything? What the fuck? Why is it doing 3D vector stuff? Huh? Oh, I think I changed something about a very low level library. So it's redoing everything. Not fun. Because that library's change was completely inconsequential for this. Incomplete information. Yeah. Everything's gonna be rebuilt now. Go. Don't give me that bullshit from before.
Well, it's a pretty quick rebuild.
I don't count that as quick, but sure. Compared to bullshit and like C++ and whatever. Yeah, it's kind of quick. Launch. Check consistent. No method. Frame shadow nil. What? Why? Frame buffer does not have any attachments. Oh, because they're not input or output ports. God damn it. And that's fine. It doesn't need to have any attachments. Okay, hold on. So, dev class. Image in. Image port. Flow. Import. Flow. On port. Maybe that'll help. I don't know. Image in. Can't I do the pass thingy? No, I can't without a context. Still did it not. Still didn't fucking do it. Undefined variable y. Unexpected identifier. Oh boy. 42. Y. Okay, yeah, fair enough. What else? 453. Unexpected identifier. Expecting bracket at image 2D. Okay, so I don't know which order it's expecting. I guess. Undefined variable shadow, yeah. Still not computing the fucking passes, though. This should not be nil allocated. Pipeline. Wait, is output somehow a... what? Buffer. It is an output. What? That doesn't make any sense. Don't think I ever used this anyway. Still nil, motherfucker. What is it now? Oh my god. Version 420. 420, bro. Why is it still not fucking allocating things? Fuck you. What am I missing? Oh, here it is. I don't think we need to worry about anything else. Did it do it now? Yes. Oh, image size is only 430? Oh, that's good. Oh, nice. I'll just fucking enable all the things. Why couldn't you tell me earlier, asshole? Or is image variables declared without using the write only qualifier? Where should the fucking qualifier for write only go, though? Don't understand that part. Image load store example. Image store example. Let's see. Also, we're almost out of time. That's a shame. Uniform layout. Layout needs to be first, though. I'm pretty sure it's not. Layout. Uniform. Right. Only. REV8. 8 UI. Alright, I also never specified the spec. Or R8 actually. Why is it 16F? What the fuck? Guess it somehow got shared? Yeah, it got shared. Wait, why isn't it updated? Motherfucker. Let me restart real quick. It's not gonna work magically, but why did it have to rebuild so much again? Undefined variable shadow. Where? It's 56. Expecting that? What the fuck are you talking about? That's how it is in an example, so I don't. Why is this a problem, you fucker? Is like shadow another keyword that I can't use? So that's what's happening. sometimes that's the thing, and then it gets really confusing. Crash, 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 another one, yeah. Why? What the fuck do you mean by this? Expecting double colon, what? Why? I don't understand. I really do not fucking understand. Fucking OpenGL, god damn it. You know, Google is cool and all, but I really love it when it just ignores one of my keywords, you know, the one that's actually important.
Oh dear.
Yeah, good stuff. Well, I don't know what the fuck it wants from me. This, as far as I can tell, this should be valid, but it isn't, so I don't know. I don't know. Fucking goddamn it. Okay, well, failure of a stream tonight. Oh well.
Can you copy it into plaster? I can't read that off the screen.
Is it still too small even at this? Make the fucking thing bigger. It's gonna be online soon anyway. Well, hopefully I can still make it work somehow. I'll try again a bit on my own tomorrow and see if I can get it working. If not, we're gonna do something else. Yeah. Trying to Google for the error, but nothing's showing up that's actually useful. Wait, hold on, this texture isn't shared with anything, so why was the text spec upgraded from an R8? What? Why did that happen? It's allocated different textures too, they're not shared at all. Very confusing. There's also some other stuff we need to like clear the texture off for each run. That's gonna be annoying, so... Not sure if that's even correct either. Okay, well, anyway, that's it for tonight. Hopefully I can fix it tomorrow. Bye-bye.